Okay, so question 61, how could the following compounds be synthesized using a Diels-Alder? There are a couple different sub-questions for this. I'm just going to do the first couple and go from there. So this question, sub-question A, is actually trying to trick you a bit. There are a lot of double bonds here, but there's only one that really matters, and that's this guy right here. Okay, so that's the only double bond that really matters. What we can do is we can abbreviate this six-membered ring, this benzene, as a phenyl or a pH, and make things a lot simpler on ourselves. Okay, so we'll do that when we do the retrosynthetic analysis. But for now, you see this double bond here. You know this is going to be the direct result of the Diels-Alder. So the double bond that you see will always be attached to the carbons that had the diene. So what this is telling you is that you're going to have the double bonds originally on, so let's go ahead and number 1, 2, 3, 4, 5, and 6. So you're going to have the original double bonds between carbons 1 and 2 and 3 and 4. And you're also going to end up, because of that, forming new bonds between 1, 6 and 4, 5. So that means that we're going to end up breaking these two bonds, and we're going to separate this molecule on the left from the molecule on the right. So we're going to have our diene over here, dienophile on the right. Okay, so let's go ahead and draw our dienophile. So 5 and 6, we'll draw it over here. So we'll have our original double bond, okay, and we'll have our alpha beta unsaturated ketone, and that's pretty much it. So we've got our carbon 6 and 5 right here. And let's go ahead and draw the other bit. So we've got to take into account carbons 1, 2, 3, and 4. So we have 1, 2, 3, 4. And we're going to have the diene here. So instead of having the double bond at 2 and 3, we'll have the double bond at 1 and 2 right here and right there. Okay. And so then we label 1, 2, 3, 4. And we'll have our phenyl group sticking off the side. So this will be the phenyl group. Okay, and if you were to go backwards, you could redraw the formation of the ring by showing electrons coming this way, and then this bond breaking over here, making a new bond here, and then this last arrow is how we get that carbon 2 to 3 double bond right there. Okay, so that would be how you push electrons to go back to the left that way. Okay. All right. So sub-question B. Again, all you have to do is identify where the double bond was or is, and that will be partially your dienophile or your diene. Excuse me. So here we've got the double bond. So we know we have a double bond here and here to begin with, which means that we must be breaking this bond here and here. Okay. So to do that, we can draw our diene on the left and the dienophile on the right. So we know that we're going to end up forming a double bond here, and a double bond there. Okay. So overall, though, we need to take into account where bonds are still made and where they're broken. So let's go ahead and number. So 1, 2, 3, 4, 5, 6, 7. Okay, so we can't forget about this carbon 7 here. So we know that we're not breaking any of these bonds right here. So we're going to have 1, 2, 3, 4, 5 carbons in the ring. So 1, 2, 3, 4, 5. Let's go ahead and number everything. 1, 2, 3, 7, and 6. We know we used to have a bond between 1, 2. We're going to end up having a bond between 1, 6 and 2, 3. So let's go ahead and draw that in. 1, 6 and 2, 3. Okay, so there's our diene. And we know we have a dienophile between 5 and 4. So 5 and 4. And then we have this ester group right here as the dienophile. Okay? So we, in this case, have two different molecules, and if we redrew the bond-making, bond-breaking process to get to the final Diels-Alder product, we would have one bond going this way. Then we could show the new bond forming between 4 and 3. So yeah, that would be 4 right here. This would be 5, and we could show the new bond forming between 1 and 2, utilizing this bond right here, this pi bond, or forming the new bond between 1 and 2. Okay, so that's if we wanted to go from the right, get the product on the left.